What I want to cover is all the things that I've learned throughout my time as a DevOps engineer, as a developer in the industry. And I happen to live here in Houston, Texas, right down the street from what used to be Compact Computers. And that's where I started my career back in '96. So I've seen a lot of stuff when it comes to writing software. And I wanted to come and share some of those best practices with you when it comes to doing DevOps as well. One of the first questions that I get asked all the time is, why is DevOps even important? And I think you should probably already know this. Like, DevOps is extremely important because it increases your velocity as an engineer, as a development team. It allows you to ship code more frequently than you did before, and hopefully more frequently than your competition. Speaking of competition, DevOps is extremely important because your competitors are already doing this. And if you're the last one in your industry to start to adopt DevOps, you're probably already behind the curve, and that can be really dangerous in an industry that we have today that moves so rapidly. We want to reduce downtime. As Heidi said before, it's almost unavoidable, but it's important to reduce it as much as possible so that when those problems do occur, you're able to correct them as fast as possible, get your system back online, and start satisfying your customers again. And reducing human error. Machines love to do the same thing over and over and over again, but humans do not. And no matter how hard we try, sometimes we'll make a mistake. And when you start to use automation as much as you possibly can, you start to minimize and mitigate the chances of having human error inside the process. And DevOps goes a long way towards helping you do some of that stuff. I've used the term DevOps a lot, but I can guarantee you that all of us that are hearing my voice right now probably don't think DevOps is the exact same thing. So what I like to do before I start a session like this is level set. And let's all agree on what DevOps means for at least the next 30 minutes so that when I say DevOps, we're all nodding our heads and say, okay, I know what Donovan means when he says DevOps. I was asked what is DevOps at Microsoft when I took one of my previous roles as the PM across all of DevOps for what now is Azure DevOps, the product. And when they asked me that question, this is what I said. I said, DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word of that sentence is value. It's not about uptime. It's not about features. It's not about getting to the bottom of your product backlog. It is about delivering value. And I think that is crucially important that we reframe the discussion around that one word. The reason why is because I go to lots of customers, I visit lots of them, and there's always the same question. Donovan, why do our developers and our operations people not like each other? I'm like, what do you mean they don't like each other? Like, they fight all the time. If anything bad happens, it's always the other person's fault, and we don't understand why. So I ask a very simple question. How do you reward and incentivize your developers? Oh, it's all about being innovative and about adding features and about delighting our customers. I'm like, okay, that makes sense. How do you incentivize and reward your operations teams? It's all about uptime. It's all about green lights on the servers. I'm like, that's interesting because the easiest way to keep a healthy server healthy is to not touch it. If the lights are already green, leave it alone and the lights will stay green. But for you to innovate and to add features and delight users, you have to go change those servers. You have to go deploy new software. And when you do that, you potentially jeopardize keeping the lights green. So when you have one team whose sole goal is to keep the lights on the server green, and the other team's goal does not align with that, these two teams start to fight against each other. So what I encourage all of our customers to do is to say, we need to have our developers and our operations teams driving towards the exact same goal. That goal is to deliver value. Heidi kind of said some of this earlier. Doesn't matter how many nines you have, right? If the software you're delivering isn't what people want, doesn't matter how reliable your infrastructure is. It also doesn't matter how great your features are if your infrastructure is not reliable and people can't use your software. To get value, to deliver value, both those things have to be true. So when we reframe the discussion, it's not about uptime alone. It's not about green lights. It's not about features. It's not about getting to the bottom of your product backlog. It's about being able to demonstrate and to prove that you delivered value to your end customers. And to do that, you have to measure uptime. You have to measure telemetry. You have to see what features are actually being used. So let's reframe the conversation around that one word, value. Get everyone in your organization all driving towards value, and great things are going to start to happen. Beyond value, there are three parts to this discussion: the people, the process, and the products. The products are the easy part. Most of our products are free. A lot of our competitors' products are also free. And I don't want people trying to do a let's compare feature to feature for every single product. You don't need the best in class. You need the best product for you and your company and the problem you're currently trying to solve. So please do not have lots of fights and arguments and debates over the products. That's the easy part. Just use what you need to get your problem solved. The harder part is the people, because your people like doing what they've always been doing. They're comfortable doing it this way. That's why they do it this way, because I've been doing it this way for 30 years and it's been working. So why would I change it? If your people do not believe, if your people do not understand that it is imperative that you start to adopt these best practices, doesn't matter what process you follow, doesn't matter what products you buy, you're still going to fail. They have to understand that the threat is the company next to you who's already doing these things. Your people have to understand that they fundamentally have to change the way that they think. That way you can then follow a process, be it agile or scrum, Kanban, whatever process that you've decided to adopt that's going to help you produce an increment of shippable software. When you're doing that effectively and your people have the process they can follow, the products are just there to aid that. So again, people are the most important, and they have to understand how important this is for them to do. You can then select a process, and I'm going to talk about how important it is to follow the process that you choose. And then you can use whatever products that are necessary to get you across the finish line. Let's talk about being agile, following a process, using Scrum or Kanban. I meet a lot of customers who aren't very good at that, but are really excited about doing DevOps. And I keep asking them, if the software that you produce is no good, why are you rushing it into production? All you're going to do is ruin your reputation, because the software is no good. It has security vulnerabilities. It's low quality. It doesn't deliver the features that they want. But man, you deliver it quickly. But crap, shipped fast, is still crap. You have to be producing an increment of shippable software that your team and your company would be proud to have their customers use. If you're not doing that, you trying to rub DevOps on it and make it better is probably just going to make it worse, because what you're going to be doing is shipping quickly software that no one should be using. So let's make sure that you're really good at Agile, you're really good at Scrum, you're really implementing Kanban or whatever process you've chosen in such a way that when you get to a point, the end of an iteration, the end of a sprint, you actually have a piece of software that you would be proud for your customers to use. That is the item that we want to be shipping quickly. Too many people put the cart before the horse and think if they automate their pipeline, they're magically going to have better software. That's not the case. The software already has to be good. You need to be designing security and quality into the product. Just like Heidi said again, I thought her session was really good about hiring testers. They're really unique. I'll use the word unique people who ask questions, as she pointed out, that we don't ask. They put numbers where letters are supposed to go and letters where numbers are supposed to go. What kind of psychotic person would do that? It clearly says phone number. Why are you typing your name there? But they do. And if your software is not designed to handle that, to validate that, to protect itself against that, bad things are going to happen. So you have to shift left quality. You have to shift left security. You have to shift left best design patterns and processes, and even what your infrastructure is going to look like, so that you're designing to optimize that infrastructure, so that you're writing unit tests at time zero and not trying to bolt quality on later. Security is everyone's responsibility. You don't worry, you don't pass the buck down the hallway to someone who's going to do the security audit. So I don't have to worry about it as the developer, because we have a team that's going to do that later, and then they'll tell me what I've messed up. No, you need to be thinking about that and designing your software such that they're just verifying that, not telling you what you did wrong. I think the same is true when it comes to quality, and I'll be talking about that a little later. So I'm going to actually give you some references near the end of this talk about how to really get good at Agile, how to get good at Scrum. And if you're saying, oh, no, we tried Scrum in our organization, Scrum doesn't work here, or Agile doesn't work here. No, you didn't, right? Because Agile and Scrum, they don't fail. Some of us implement it well, some of us don't. But the actual process, the rituals, the rules that you follow, the meetings that you have, they're all there for a purpose. They're all there for a reason. And if you do them all and follow the guidelines, you will succeed. I have 100% confidence in that. Those that I see failing are those who said, we don't need a daily stand up. I don't need to meet with you every day. And there's value in that meeting that you've forgone. Or we don't do those anymore because it took us an hour to do them, right? Daily stand-ups were supposed to be 15 minutes. What were you doing in a stand-up for an hour? No wonder you stopped doing them. But the answer wasn't to stop doing them. The answer was to start doing them correctly and to start getting what you're supposed to get out of that particular meeting and having it every day like muscle memory. Same thing with your planning meetings, with your retrospectives, with your sprint reviews. There's a reason those meetings are there. There's goals that you need to get out of those meetings. And if you follow what you're supposed to be doing, I've never seen a team fail that tries to implement Scrum before. And I bet you, if you think back on every time you've had a failed Scrum implementation, there were corners that you cut. There were rituals you did not do. There were things you were told to do that you thought you were smarter than or wouldn't work in our organization. And that's why you failed, not because of Scrum failed. So please decide you're going to do something and commit to doing it well. And what I've noticed is those that are really, really good at Agile is why they want to start doing DevOps, because they're producing these increments of shippable software every 2 weeks, every 3 weeks. But they're realizing it's taking them months to get that code into production. And it shines a light on the fact that you need a better process of getting the code from the hands of your developers into the hands of your users. And that's why we shine this light on DevOps right now. Lots of people are good at Agile and they want to get that code to their users faster. So please be good at your process, and then you'll reap the most benefits when you start to implement DevOps. We've done the same transformation inside of Microsoft. Matter of fact, we're doing it right now. We do it all across our organization. I'm going to be talking about a specific team's transformation, and it's the team that actually built Azure DevOps. We used to ship Azure DevOps back when it was called Team Foundation System every 3 years. That's a long time to go without shipping software, but we just shipped it every 3 years. Today, we ship it every 3 weeks. And even that isn't actually accurate. We ship it twice a day, hot fixes and things like that. But big major releases, we ship every 3 weeks. But every day, multiple times a day, we're pushing out hot fixes, we're pushing out updates, we're pushing out enhancements to that product. How in the world did we go from shipping every 3 years to shipping multiple times a day? We started to develop these habits, and I'll talk to some of these a little bit later. But one of them that I really like is having a production first mindset. Many of us who've developed software for a really long time have all been in that scenario where we develop software in a waterfall method or even in a more agile method, but we don't ship very often. So we're kind of scrum butt. We don't ship every time we get a chance to ship. So what we do is we build up this big, large clump of software that we now want to ship. It's been 6 months, it's been 9 months. And we haven't even thought about how we're going to ship it. We were so laser focused on writing the software, getting to the bottom of the product backlog or getting that last feature put in. And then all of a sudden we pat ourselves on the back because we're code complete. And then we realize there's a whole nother mountain we have to climb because we haven't thought about how we're going to actually deploy this into production. There's a whole series of problems that we haven't even started to address on how are we going to get the infrastructure provisioned? How are we going to get the security set in place? How are we going to get the right access to the people that need it so that they can deploy our software out of there? Did we scale or design our application to fit on the infrastructure that we actually have capacity for? If you thought about production first, even before you wrote a single line of software, you would have an idea of how we're going to get into production. You can actually lay that pipeline or that highway into production before you write a single line of code. And I've done this. I've been on teams where we had an idea of what we needed in production. We started creating infrastructure as code files, and we created an entire pipeline that would stand up and deploy our dev infrastructure, tear that down and stand up and deploy our QA infrastructure, tear that down and then deploy and stand up our entire production environment. So at time zero, before we wrote any code, we actually had our entire pipeline laid out with the infrastructure. So our developers knew exactly what capacity they had available to them. They knew exactly what the landscape of their environment was going to be. And when they went to design their solution, they made sure that it was going to fit in the environment that we already had. And because we already had the DevOps pipeline laid out from a repository to production, the very first commit that a developer pushed to that branch started moving its way down the pipeline. And all we're doing now is adding value on top of value on top of value, not having to worry about how do we get it into production a month from now, a week from now, or a year from now, because that line has already been drawn. That pavement has already been paved for us. So getting into production now is very, very easy for us. Again, I kind of mentioned this earlier about shifting left. Shifting left is the practice of moving towards the developer things that they used to put off and ask someone else to do for them. Please go test my code because I'm not going to write unit tests and go find all my bugs for me. Please go do a security scan for me because I'm not going to write any code that protects against SQL injection attacks. I'm not going to protect my code from denial of service attacks. So I'm expecting you to go do that stuff. And what we find out is it's very expensive to do that. Because if you're not thinking about quality and you're not thinking about security, you're going to write your code in a specific way. That code becomes very brittle and very difficult to change when they get identified later. If I were thinking about that beforehand, then I would have designed my software differently. Again, I'm referring to Heidi's session once more. Test-driven development is hard. But I know as a developer, when I started thinking about tests more often, I would literally write my code differently, even though I knew I wasn't going to write the code in the test till tomorrow. Knowing that, man, that's going to be hard for me to get in all the nooks and crannies of these if statements. Let me go ahead and flatten that. Let me go ahead and do a shortcut logic so that it's easier for me to test this code tomorrow. But you got to make sure you pay that down, that technical debt, and write those tests. But I know that it immediately made me a better developer by thinking about how I'm going to test the code tomorrow. Team autonomy, this is something that's fundamental to being a good Scrum team, to being a good Agile team. Your team has to be empowered to do whatever they need to do to succeed. The best example I have is where I was on a Scrum team that actually replaced our product owner. We realized that our product owner, whose responsibility it is to prioritize our product backlog, wasn't doing a great job because every sprint review we went to, our stakeholders were disappointed. Reason why is because what we were doing was not important to them. So what we ended up having to do was replace our product owner with someone who had a better idea of what our end users needed from the software. They took one look at our product backlog, completely rearranged the order of the items that we delivered. We delivered our next sprint and everyone was happy. But the team was empowered to do whatever it needed to do to succeed, even if that meant replacing the person that was currently guiding the ship based on data that we had gotten from our sprint reviews saying that we're not delivering the right thing. I'm not going to talk about the infrastructure as code yet because I have a slide just on that and I'm a big fan of it, but also being customer obsessed. It's something that I take very personally. I don't look at people who use Microsoft products as customers. I look at them as partners. And I think when you really treat them as, I'm just an employee of your company and I want you to succeed because when you succeed, I succeed, it changes the way you think about things. You stop taking shortcuts. You stop doing what's easy for you as an engineer and start doing what's right for the customer. Because I only have to pay that price once. But if I have a bad product or a product that's not easy to use, our customers have to pay that price every time they use our software. Yeah, it was a little harder for me to write to make it more intuitive or easier for you to use, but I only had to write it once and you have to use it every day. So make sure you focus on your customers because they are crucially important to your success. If they don't like your software, why are we writing it? Quality, quality, quality. I'm old enough to remember when I didn't write unit tests. When I didn't believe in unit tests. If I don't write unit tests, I can develop a lot more code, right? And again, I had a whole QA team whose responsibility it was to find my bugs. If I write tests, what are they supposed to be doing, right? So me not writing tests, that was me being a good citizen and allowing other people to have a job. No, it was nonsense. I was being lazy and I was being immature. Now it's interesting because as I write code, I feel uncomfortable if I don't write unit tests. It's like riding my motorcycle without a helmet. I could do it, but I don't because I would feel unsafe. It only takes one crash, one mistake for me to wish I had my helmet on, but I didn't. It only takes one crash or one mistake for a bug to escape into production that could have been caught by a unit test that is going to cost you hundreds of thousands, if not millions of dollars because you didn't take the time to write something as simple as a unit test. And there's a lot of great practices that you can do to writing unit tests. It's going to be a muscle you're going to have to develop. But I promise you, you will actually become a faster developer when you have unit tests. To me, they're like the safety net that protects me from mistakes that I would otherwise make. I remember when I was younger and I saw a big giant method that I was using in a shared piece of code. I really wasn't sure how it worked, but I knew that that's what I needed and I needed it to be slightly different. I was so afraid to change it because we didn't have any tests to tell me if I broke it. I would just copy the entire method and paste it and rename that method. And then I would call this other one. I was only a line or two different from the original one, but that way I knew I wasn't going to break anyone who was using the original one. But now we have twice as much code And we potentially have twice as much technical debt because any bug in one is probably a bug in the other that's going to have to be fixed twice because I didn't have the confidence to change the original code because there were no unit tests. I cannot stress enough how important it is to start building that safety net. Unit tests are great. They're fast, they're atomic, they're repeatable, but you also need integration tests. Just because I work in isolation doesn't mean I play nice with others or that I throw the right errors at people who try to abuse my API or pass me parameters that they shouldn't be passing me. I was just teaching this to my nephew who's wanting to be a programmer that you need to throw errors the moment that you see something is wrong because it's going to make it easier for you to troubleshoot. You don't want to have bad data make it 4 or 5 calls back up the stack before you throw an error because you're going to think that's where the problem is when in actuality the problem is 5 calls ago when you could have told me that I did something wrong but you didn't. So you want to make sure that the integration test make sure that you're able to determine that everything works great, and if something should be thrown as an error, it's thrown as close to the problem as possible and not propagated up the stack. I'm also a big fan of load and performance tests. When you start talking to SREs, they start talking about SLOs, SLIs, and making sure that they can meet their SLA. Well, you got to run load and performance tests to prove that those indicators are tracking the right information so that those objectives can be met and your customers can trust that SLA that you've actually promised them. Security cannot be stressed enough. It needs to happen along the entire path. The term DevSecOps to me is a little bit of a I don't know. It's just not my favorite term because it sounds like it's only in the confines of what a lot of people are defining as their CI/CD pipeline. But security starts from the repository sitting on your developer's machine. You need to make sure that that machine is secure, that it has multi-factor authentication, that your hard drive is encrypted, that it takes a lot of work to get to the software that's on that machine. Because if I steal your laptop, I have all the history of every change you've ever made in your Git repository locally on that machine. We also need to make sure that not only the pipeline itself is secure and that the code runs securely in production, but that the packages that we use are secure. If you're using containers, that the layers in my container have been scanned to make sure there's no vulnerabilities, that I don't have to go back and repatch my Docker file to make sure that I'm using layers that have actually been scanned and are protected from vulnerabilities that might jeopardize my customers. I want you to think about security from the time you start typing while you're all the way till your code is running in production. I want you to do pen test. I want you to make sure that you're only using things like Key Vault or HashiCorp Vault or some way to securely store those connection strings and that sensitive information. You're not just scribbling it around inside of environment variables or on web config files on your hard drive, because if that node gets compromised, then all of a sudden so does that data and that sensitive information on that node. But taking that information off, scaling those nodes is going to be easy, and I know that they're all secure. Even if someone were to be able to get onto one of those machines, there's nothing on that machine that they're going to be able to use to jeopardize the security of the entire system and or my organization. So I really want you thinking about security from the time you start typing. Pull request workflows are another great thing. I wasn't a big fan of Git. If you go back and look at some of my old talks, I really was not a big fan of Git. I'm just like everyone else. I don't like change. But then I started to understand why that pull request workflow that's sort of innate and built into Git is so powerful because it gives us an opportunity to review the code, not only visually, but we can actually try to compile the code and make sure that we haven't broken the build. We can run those scans I was just talking about to make sure that the changes that we're trying to make are going to be secure. We can actually do static code analysis to make sure that the code looks and feels just like we would expect everyone else to write the code to look and feel, so that it's easier for me to go back in and fix someone else's bug because the code looks like I would have written it myself. That ability to also stand up an environment as part of your PR so that before we merge it into our main branch, I'm able to actually run the code in an environment, test that it does what I want, and saving and keeping my main branch pristine before we start introducing changes that we're going to have to somehow back out or overwrite. So I really want people to think about the pull request not as a burden of you having to review code, but an opportunity for you to preemptively go ahead and scan, run unit tests, build your code, and make sure that the code that you're pushing into your main branch is really, really top-notch code that we want to put over there. Infrastructure as code. Again, I worked at Compact Computers. I could go into the server room and I could actually physically touch the ProLiant server that was running my software. Infrastructure as code made no sense to me because it's like the server never changes. Why do I need infrastructure as code? But then you go to the cloud and you realize that environments can be temporary. I can spin one up and tear one down at a moment's notice. You can do that if you use infrastructure as code. I don't want to have to email someone, have them go into a portal of some sort, and then click around to provision a VM for me. I want to be able to define in my pipeline what infrastructure that I need, run that pipeline, and have that infrastructure automatically stood up for me. Having that power and harnessing that gives me the ability to have temporary environments and save myself a lot of money because I don't need those environments the entire time. I can have them stay there for as long as I need them and then destroy them, saving my company money, and then only spin them back up again when necessary. Being able to have infrastructure as code also gives me disaster recovery. I remember having a system go down and it's all hands on deck. Everyone come back into work. I don't care what time it is. I'm ordering takeout for everyone, but we're sitting here as we manually reprovision the entire environment, double checking and triple checking because it's all in Word documents. And there's no way for us to automate this deployment. When you start using infrastructure as code and you can spin up an entire environment by just running a deployment, the next time you ever have a disaster and an entire data center goes down, you getting back up and running is simply running another pipeline with a parameter change saying use this environment instead, and your entire infrastructure is back, including your application. Infrastructure as code is one of the most underrated and powerful techniques I believe people need to start to embrace and embrace early. As I described earlier, I actually lay down my infrastructure as code as the backbone of my DevOps pipeline before I write any application code. I want to know that I can stand up my environments securely and quickly, and then temporarily, and then go ahead and lay my code on top of that particular environment. It helps with reviewing changes to make sure that no one makes a mistake because you can use those in PRs just like I just described. It helps making sure you have no snowflakes and the only information on how to provision that machine is in Donovan's head and Donovan's on vacation, which means we can't deploy today. That's nonsense. Take that information out of my head, put it in a file inside of source control, share that information with everyone, and allow your pipeline to automatically deploy that into production for you. If you don't take anything else from my talk, make sure you go and you investigate how important it is to use infrastructure as code. And I don't care what infrastructure code tool you use, just make sure that you can provision your environment. How much confidence do you have in your infrastructure code? You should be happy to go delete every resource group you have in every cloud provider and push a button and have it all back again. I can actually do that. And it frees me and makes me feel so much more powerful than it did before. So to wrap up, I want to give you a few resources that I think you should use. If you're implementing Scrum or Agile, everyone in your organization needs to read the first book here. If they're just team members, so everyone in your organization needs to read the first book. If they're Scrum Masters, then you need to read the second book and the third book. These books are going to help you learn from the mistakes of others and actually be able to control and protect the Agile process so that it can be successful in your organization. When you're good with these resources, then you need to go start reading some of the DevOps resources. The Phoenix Project is become the gold standard. Like everyone has to read that book. It's a rite of passage now. And then there's some other great books like the Unicorn Project. And then the one that I think started most of this is Continuous Delivery. These books were fundamental to making sure you understand the values and the best practices of automation, thinking about how you bring the people and the process together so that your company can outpace your competition. So that's what I wanted to come and share with you. Hopefully you got a lot out of that. If you do have questions, I think we have a Q&A that's coming up, and you can also reach out to me at Donovan Brown on Twitter.